Hi, Jim from AquaTurf International here. In this video, we will discuss golf course irrigation system, wire, and connections. There are basically two categories of control systems used on golf courses, decoder and satellite. For this discussion, we will focus primarily on decoder style systems since the industry has trended in that way over the last decade or so. Grounding techniques and equipment is discussed in a separate video. A golf course irrigation system consists of miles of wire connecting all the sprinklers to a central computer. A typical golf course could have 150,000 feet or more of wire installed. In a decoder system, the wire not only carries the power to activate the sprinkler, but also the communication data to tell each sprinkler how long to operate and more, such as diagnostic data. The data sent along the wire can vary by control system manufacturer. Obviously, reliable wiring is critical to the efficient operation of the system. Not only is there a lot of wire, but there are also thousands of wire splices buried in the ground, as well as connecting the wires to sprinklers and necessary grounding devices. Reliable wire connections are critical, as well as adequate grounding to protect against lightning surge. Remember, there is only one letter difference between irrigation and irritation. Inferior quality wire, wire splices, and grounding will provide much more irritation than irrigation. Wiring is especially important since troubleshooting, identifying, and solving the problem can be difficult. Water leaks are much easier to find. They normally just bubble to the top, not wire failures. I'm joined today by Joe DiRienzo, Director of Landscape Irrigation and Low Voltage Lighting with PAIGE Electric. Joe will help us discuss some of the things to look for when selecting your golf course wire and splices. Joe, tell us a little bit about yourself and PAIGE Electric.
Well, thank you for having me here, Jim.
Our pleasure.
PAIGE Electric is a wire and cable company, a worldwide wire and cable company. We manufacture insulated copper wire and cables, waterproof splicing products, and earth grounding components to protect irrigation equipment from lightning damage. Today we're here to talk about wire and cable and splices and how critical splices are to the electrical system. With, as you said earlier, decoder systems being in favor today and being used more and more on most golf courses, it's absolutely it's absolutely critical that we choose and use proper splices to make these connections. We're basically taking from a conventional or satellite system to a decoder system. We're actually doubling the amount of splices that we make in the ground. The weakest part of an electrical system are the splices, and so we can see that by doubling the number that we're going to make, we have to make sure we choose and make proper splices. So for instance, in a conventional or satellite system, if we had 40 solenoids, we'd have to make 41 splices work perfectly to get our 40th decoder to work. On that same system, if it were a decoder system with 40 decoders, we'd have to actually have 82 splices made perfectly and working perfectly for that 40th decoder to work. So we can see by doubling the amount of splices, we're also doubling the amount of possible connection failures. In order to make proper wire connections, we need to follow 4 critical steps. And this is for any wire connection, whether it's 18 gauge or 2 gauge or 3/0. The first step is to make a good mechanical connection. That's joining the cables together. The second step is to insulate that connection from short or shock. The third step is to waterproof the connection. And the fourth step is to provide something called strain relief. For our most common cables, 18 gauge solenoid wires, 14 gauge and 12 gauge wires that we're using on decoder systems and general irrigation systems, the most commonly used and the best product we feel out there is the 3M DBRY6. This product combines all 4 of these steps into one product, and we'll show you that here as we go along. So the 3M DBRY again combines all four of these steps. The first step is to make a good mechanical connection. This connector has a wire nut to make that mechanical connection. The second step is to insulate that mechanical connection, and the plastic of the wire nut insulates that connection from short or shock. So the first two steps are taken care of by the wire nut. And choosing a good wire nut is critical, as we said earlier. If we look at the design features of a 3M wire nut versus a competitor's, we can see that just the size of the connector is different. A 3M connector, the darker colored connector, is bigger, more robust. It's actually square metal, and it has a darker color because that's a polymer that 3M puts on there that helps it make a better connection to the copper cables. The other feature to this wire nut is that it has expansion pockets on either side of the wire nut, either side of the connector, where it'll draw the cables all the way into the top of the connector, ensuring a good bite onto the copper conductors and maintaining that bite and connection throughout temperature expansion and contractions that we see in the buried ground environment. Another neat feature of the 3M connector is an anti-slip arm. It's a little piece of metal that digs into the cap of the connector, where when you're twisting wire nuts on, some of the other connectors will break away and slip, and you just twist and twist and twist. That anti-slip arm keeps it from breaking, and you ensure a very good tight connection. Again, drawing the wires all the way into the top of the connector, and taking care of the first two steps of our four critical steps.
It's obvious in the drawing that wires are drawn much farther in on the your product on the right.
Right.
And much stronger than the one on the left.
It's a fantastic connector. It's won all sorts of awards in the connector world. The third step is to take that wire nut and the wires and push it into the tube with a gel. The gel waterproofs the connection, and we want to make sure that that wire nut is pushed all the way to the bottom of the tube, displacing the gel to the top of the tube and making sure we have the best waterproof barrier possible. The fourth step is the strain relief, and when we push this lid over on the connectors, there's a ball inside on the bottom of the lid. It applies pressure to the connector, which is the strain relief, so that if we go and pull and tug on these wires, the wire nut stays in place. And a good connection is, we should use a good connection for insulated copper wires and bare copper wires. Doesn't matter if it has insulation or not. We want to use a proper wire connection. We never want to use homemade connectors. We've seen people use Tupperware. We've seen them use wire nuts and dip them in glue and other types of epoxy. It's never a good idea. They're not tested. They're not approved. Use products that are UL or CSA listed. And something as simple as following the instructions is another key ingredient in making a good wire connection, Jim. When a manufacturer submits a product for testing at UL, which is Underwriters Laboratories, or ETL or CSA, they submit instructions that say you make this connection and follow these steps. And then that's how they test it. If it says strip the wire back 3/4 of an inch, you strip the wire back 3/4 of an inch, not a 1/2 inch, not 1 inch. So follow the instructions, make sure they're done properly, otherwise you may nullify the UL listing of a product.
Joe will now share with us some details on the 3 different types of wire that is typically used on 2-wire decoder systems.
The 3 most commonly used 2-wire system cables today are twisted pair, unjacketed with thicker insulation, twisted pair with a round, loose-fitting jacket, and flat parallel with a tight-fitting jacket, commonly known as maxi-type cables. Each cable is designed with features and benefits to help address some of the most common decoder cable system problems today. which are wire and cable faults due to insulation damage from rocks and other sharp objects, and insulation knife damage to the inner conductors of jacketed cables. Design and manufacturing begins with the types of insulation and compounds we use for the single conductors and jacketed cables. And when we compare the two main compounds, polyethylene, PE, and polyvinyl chloride, PVC, we see that there are some differences. When we look at the inherent qualities of polyethylene versus PVC, we see that polyethylene performs better in the things that we measure, like insulation resistance, water resistance, abrasion resistance, cut-through resistance, and chemical resistance. Polyethylene outperforms PVC. Because of its durability, it's also tougher to work with when we're doing our splices and jointing. PVC, on the other hand, is a softer, more pliable material and easier to work with when we're doing our splicing and jointing. But we use both polyethylene or a combination of polyethylene and PVC in our decoder wire cables. The first type cable is the 2-wire unjacketed twisted pair cable. This is a high-density polyethylene. It has extra insulation, 75 mils of insulation, which is greater than our standard solenoid or satellite cable that we use. It's twisted together, and the twist gives it tensile strength. It keeps the cables together, and it also creates inductance and a slowing down effect of electrical currents induced by lightning. So we get some added toughness, and we get some added lightning protection with twisted cables. We don't have to worry about one of the main problems, which is damage due to knives, because there isn't a jacket on this cable. All we need to do is remove the ends and begin our splicing or jointing. Because this is a thicker cable and high density polyethylene, it is tougher, stiffer to work with, and does affect our jointing and splicing. The next type cable is a twisted pair, loose-fitting jacketed cable. The inner conductors, again, are loose-fitting inside the jacket. They're made out of high-density polyethylene, and it's our standard 14-gauge direct burial solenoid satellite cable. The polyethylene jacket is round and designed to protect the inner conductors. And it's loose-fitting so that all we need to do is to score the outside of the jacket, and we'll be able to slide it off very easily. We recommend a tool like this. It has a blade in the center. You can adjust the depth of the blade so we don't cut through and into the inner conductors. We put it over the cables. We spin it around like so, just scoring the outer jacket. Break it loose and slide it right off like so. The other feature in this cable is a ripcord. So if you want to expose more of the conductor without using the knife, we can take this and rip this down through the insulation, exposing more of the inner conductors. And finally, the third most commonly used cable, again, is our 2-wire flat maxi type cable. And this is, the inner conductors are made out of PVC, softer, more pliable material for our splicing and jointing. We have a heavy duty flat polyethylene jacket. And it's tight fitting to the conductors. And by tight fitting, we mean that it's difficult to remove from the inner conductors. The recommended splicing tools are a product like this. It has a blade here for flat cables. You put it over the cables and you scrape. And what this tool does is scrape off the insulation. And you can see that there's a high chance of damage to the inner conductors with a tool like this. The other tool that's used is a razor blade. And again, when using a razor blade around the to slice into the jacket, it's very high potential for damage to the inner conductors. So we recommend when using these tools, using any of these tools, to remove a section of the jacket. And now all the cables that we manufacture have ripcords in them on either side of the conductors, so we can just pull the nylon ripcords through the insulation and expose more of the inner conductors without exposing them to potential knife damage. So those are the three types of cables: twisted unjacketed, twisted jacketed with a loose fitting jacket, and maxi type cables with a flat tight fitting jacket. We hope you found this informative. Thank you.
Wire marking tags are used in decoder systems to help with the maintenance and troubleshooting of a system. And these are tags that we can write important information on at changes of direction on the golf course inside of a valve box usually, that tell us maybe the voltages that when we installed the cables, tells us where the cable is going to, if it's going down maybe the 4th fairway, if it's going to a controller or what have you. Any information we want to know, these tags will help us when we want to go back and do some work on the system.
Makes it much easier for the maintenance staff who may not have been there during construction to know, rather than having to check the wire with a voltmeter or something else. They can clearly see where the wires
Where the wires are. It's just information that helps with the troubleshooting, which is, again, like you said, helpful to anyone involved on the golf course.
And no matter whose connection they buy, it's going to break at some point in time, right?
Exactly. There's, whether it be lightning or splicing or some other feature, somebody rips through it with a shovel or
Correct.
a digging tool.
Right.
There's always something that's going to be done on the golf course, maintenance-wise, on the electrical system. Another item that we see and use is a fuse device. And this is similar to an isolation valve on a hydraulic system. It's just an isolation fuse device for the electrical system. And we can put these at the different change of directions on the golf course in a valve box again. There are fuses in there that we can pull out and push in to disconnect the system or activate the system to help us isolate the different parts of the electrical system when we're having reliability issues.
I see. That's very handy.
Very handy, very useful. And then we also have products that are a little lower tech, that are reenterable and reusable. These are RC connectors, and these are brass bus bars encapsulated in rubber, so they're waterproof. And there's no printed circuit board like a fuse device. They're easy to get into and out of, and that'll also help us disconnect or connect the decoder systems. I just want to reiterate that it's important to choose wisely, make the connections using best practices and the best products available, and it will help the reliability and help the system last longer and create a lot of reliability in the system.
Well, that's great, Joe. We appreciate all that great information. And so, to summarize, it's important that you follow the specifications for the products that are specified by your designer, no substitutions, and install it properly and train the staff, the contractor staff, properly in these procedures to make sure that you have more irrigation and less irritation. Thanks for watching, and please stay tuned for future AquaTurf International videos.